Alright, good day student. As you can see, you are required to find the blue area. You are given a circle, and the circle will have a hexagon inscribed in the circle as shown. But I would like you to know that this drawing is not 100% drawn to the scale, but the information is sufficient to solve our problem. Alright, let's proceed. This is the blue area, or this blue area outside the range of the hexagon. So the first thing we have to know is to find the center of the circle. Let here be center of the circle, and we can call it O. Let's call it O. So draw a line, join this line, draw another line here, draw another line to this point. I can label here B, label here J, and then label here C. So once we have done that, you will know that if here is the center of the circle O, here will be OB is the radius. If here is the center OB, OJ will be equals to what? OJ, and it will be also equals to OC. So this is the first thing you have to know. And then the second thing you have to know before you proceed is to you have to find the interior angle of the hexagon. Interior angle of the hexagon. This is interior angle of the hexagon. Abbreviation. So it is equals to n minus 2 multiplying 180 degree divided by n. In this case, n is equals to six-sided polygon, which is a hexagon. So in this case, we can substitute n by 6 and divide by 6, so that we have 120 degree. Now we have gotten the interior angle of the hexagon. We can now know that this angle here, or this angle here, is equals to 120 degree. OJ is perpendicular. We assume that this is OJ is an angle, like OJ is an angular bisector, so that here will be 60 degree, here will be 60 degree. So in the same, we say that OJ is equals to OB, and they are equal to angular bisector. Angular bisector of what? Equal angles. So they are angular bisector of what? Equal angle. Because angle here, this total angle is 120, this angle is 120, total angles of a regular hexagon. Here is 120, here is 120. So OJ, OB bisect it into 60, here will also equals to 60. So that once we have done that, we now have 60 here, we have 60, and OJ is equals to OB. They are all the radius of the circle. Since here is 60, since here is 60, the remaining angle here must be also 60. Reason I emphasize on this is for you to know that I can now clean here. Reason I make such reference is for you to know that if here, we can call here Q. Notice that QC is equals to what? Is equals to BJ. Is equals to BJ because they are the side of the regular hexagon. QC is equals to BJ is equals to CJ. They are all side of the hexagon. Side length of hexagon, regular, remember to put regular, are equal. So they are equal, so which means here will be also 16 cm. And then from triangle, this is triangle BOJ, you see that BJ BJ is equals to JO is equals to what? BO. So the reason is that they are all radius of the circle. They are equal to the radius of the circle, which means they are also equal to 16 cm. Because the reason is that triangle BOJ is what? Equilateral. You know the properties of equilateral triangle. So 60, 60, 60 suggests that the triangle is what? Equilateral, which means all the sides are equal. That's why the radius is also 16. Now we are getting the radius of the circle to be 16. I can now clean here. This is only applicable when the polygon is hexagon. You cannot prove it for maybe pentagon, octagon, because once one of the base of the angle is 60, and then we know that they have the same angular bisector, and here is 60, the remaining angle must be 60. So all of the angles turn up to be 60. Since that gives us equilateral. That's why this side, opposite side of the hexagon, give us what? Give us 16 cm as of the side of the hexagon for what? The triangle BOJ. I don't know if you understand. We're able to get here to be 16 cm because the angle already showed us that the triangle is equilateral, and this is only applicable when it is equilateral. When the polygon is hexagon. If it's pentagon, octagon, or other type of polygon, you may not get this length to be 16. I hope you understand it now. Now we have gotten the radius. We can now find the blue area. So let's proceed to solve for the blue area. The first thing you have to know is, let us find the area of the circle. Area of the circle, we can call it A, is equals to pi r squared. Mind you, this is equals to r. Pi r squared. So from here, have A is equals to pi in bracket 16 squared, and then we have 256 pi cm squared. Now the next is to find the area of the hexagon. You know how to find the area of the hexagon. This is hexagon, not drawn to scale. Every of them join to the center of the hexagon. These are similar triangle. All these triangles are equal. So we have one of our triangle. Here is O, here is B, here is J. So we have 16 here, 16. We have here to be 60 degree. So area of the hexagon is equals to what? How many triangles do we have? 1, 2, 3, 4, 5, 6. 6 triangle is equals to 6 times what? Area of one of the triangle. Area of triangle what? BOJ. Is it not very easy? So area of the hexagon is equals to 6 times area of one of the triangles, since that in this case is BOJ, since the triangles are all equal. So in this case, I can call here A1 to be easy. So in this case, we have 6 times area of the hexagon, already getting 2 sides. So half times 16 squared sine 60 degree. So simplify it. We have A1 to be equals to 3. We get 3 here. 6 divided by 2 give us 3. 3 times 16 squared will give us what? We have 384 times what? Sine 60. 60 is a special angle. That will give us root 3. Root 3. So we have what? what do we have? Six times 16 will give us what? Let me use my calculator. We have, this will give us 3. So in this case we have 16 squared times 3. So here we have 16 squared times 3 will give us 768 multiplying sin 60 is root 3 over 2. And that gives us what? Divided by 2. 768 divided by 2 will give us what? 384 root 3. So cm square, remember to put the unit. So the blue area, therefore blue area will be equals to what? Area of the circle, because it's the circle is inside the circle, which is a minus a1. So we have 256 pi minus 384 root 3 cm squared. So simplify further. If you simplify further, you have what? What is common between these two terms? Use a calculator. We have 128 in bracket 2 pi minus 3 root 3 cm squared. So that is the area of the blue area. So in this case, therefore, blue area is equals to 128 in bracket 2 pi minus 3 root 3 cm squared. If you enjoyed this video, before you go, please click the subscription button to encourage me to bring more videos for your view. Like and share so that others will see this video. Also click the notification button. Whenever I have new update, you will be the first person to watch the video. I hope you enjoyed this video. See you in the next lesson. Bye for now.